using this table again. Actually, we're not even using this table anymore. We're going to use the scientists propose this equation is now replacing this table. So we actually don't need the table. As the model for the depth of the water, okay, find the area of the cross-section of the river based on the model. So using this instead of this, we want the area. So area is simply going to be an integral. Now, for here, wasn't it from 0 to 24? Wasn't the river 24 feet wide? So this is going to be from 0 to 24. And isn't your function f of x? So instead of writing this, could I just simply put f of x? Isn't that given? And wouldn't this be dx? F of x is given. There it is. And then I want my answer. We'll put that in your calculator, and you would simply get 122.231 feet cubic feet. That would be your answer. Now, that is more than the approximation here. Got it? That is actually more than the approximation. Now, that is square feet. Sorry, it's area, square feet. I said cubic. Now for D. D is a little bit more tricky. It says recall the cubometric flow, all right, is the product of the cross-section of velocity. To prevent flooding, the water must be diverted if the average value of the flow exceeds this amount over a 20-minute period. So what they're going to do is they're going to take a 20-minute period, meaning from 40 to 60. They're taking from 40 to 60, taking that 20-minute period. And they're wondering, during this 20-minute period, it wants you to use your answer to find the average value, and then ask, does that value indicate the water will be diverted? Meaning, is it going to flood? Do they need to divert it because it's going to flood during this 20-minute period? So basically we're trying to think, will the value, the average for this 20-minute period, be bigger than this? And that's what we're trying to see. Because if it is, we have to divert the water. Now how do we find over this period the amount of flow? Well, for the previous problem we dealt with earlier, we want average, correct? I want my average volume. So what's my interval here? How long is that? That's 20. Now, my interval is from what? It's not 20, 0 to 20. It's from, isn't it from 40 to 60? Now, isn't the flow going to be, let's say, isn't, how do you say it, the volumetric flow is the product of the area and the velocity? Now, what's the area? Well, isn't the area now this? Instead of, before it was 115, isn't it this now? Then we have a more accurate answer. So it's 122.231. And then don't we need the velocity now? Isn't that v of t? So won't it be that number times v of t? Won't that be dt? Now could you do that on your calculator? Yeah. When you do that on your calculator, you get 2181.913 cubic feet per minute. And when I got that, I go, oh, okay, there's my answer. That's how much it is. Does it okay, use it, find the average flow. I got my average flow. My second part of the equation, do I have to divert? Is this, over the average for the 20-minute period, is this larger than what they need, than what it can handle? So do you have to divert? The answer is yes. Does the value indicate you need to divert? Yes. Why? Because this is larger than 2100 cubic feet per minute.